Greetings, Wildcats and Honors Chem. It's time for one more rendition of a video lab. This video lab is entitled Relative Reactivity of Metals. Well, let's get started. Guys, the purpose of today's lab is to investigate the relative reactivity of four metals from various places on the periodic table. We're going to test magnesium, calcium, aluminum, and zinc. And after we observe their relative reactivity with hydrochloric acid, we're going to try to make a few conclusions on the pattern of reactivity on the periodic table, and maybe even look at what might cause that pattern of reactivity. All right, so here's what we need. Okay, as usual, let's assemble our materials. Well, we need some magnesium ribbon. I have a little container here. Some calcium lumps. Need some zinc foil, and again it's inside this little container, and some aluminum foil. I need some hydrochloric acid. The concentration is called 1 molar, 1 m. It tells how strong the acid is. It's actually not a very strong concentration of hydrochloric acid. We need a 10 milliliter graduated cylinder, some forceps to handle the metals with. We need 4 large test tubes. That's what we're going to do our reactions in, and you can see that they're labeled with the identity of the elements that are going to be reacted in them. We want a digital thermometer because part of our reaction, besides just watching the reaction between our metals and acid, we're going to actually monitor the reaction with temperature, see if there's a temperature change. And finally, somewhere around here, I have a plastic pipette that I can use to adjust the volume of my acid. Okay, well, looks like we're ready to go. Okay, first it says to label 4 test tubes. I've done that already. Next, we're going to measure out 5 milliliters of the hydrochloric acid using the graduated cylinder. And I'll do that for the first one, and then I'll stop the video so you don't have to just watch me spend time measuring 5 milliliters of acid into each tube. So here we go. I'll adjust that to closer to 5 milliliters, and I'll pour it into the first test tube. Okay, now I'll stop the video and I'll repeat that for the other 3 test tubes. See you in a minute. Next, I'm going to take the initial temperature of one of the liquids, because if we're going to measure the temperature after the reaction, we might want to know how much the temperature went up. You can see right now room temperature is a little on the chilly side, about 18.8 C. I'm going to just put the temperature probe into the first test tube. Now, I won't have to do the initial temperature of all 4 test tubes, because you would think that this liquid being out at the temperature, room temperature the whole time, all those test tubes are going to start out at the same temperature. Okay, so initial temperature looks like it has stabilized. Oh, just went down a little bit. About 18.5 degrees C. So we'll jot that down on the data table where it says initial temperature of acid. Class, we're ready to do our first reaction. So the lab says, using a forceps, place the piece of magnesium. So I'll kind of put the magnesium in front of the camera. You can see it's sort of not really too shiny, but kind of a little metal kind of strip. It actually, magnesium comes in several forms, but this one's in strip form. You can see it's kind of a thin strip of magnesium metal. I'll just pop it into the test tube and we'll watch. Okay, it looks like you guys can observe what's happening to the magnesium as soon as I dropped it in. I'm going to be quiet. Hopefully you may be able to even hear what's happening in the test tube. If you can't hear, I can hear a little bit of a hissing noise that's coming from the bubbling of the magnesium in the acid. Okay, so what I'm going to do is I've started timing this, and it says to let it react for about 3 minutes. And so what I'll do is, again, I'll stop the video and I'll come back. Now that you've seen what's going on with the magnesium and the acid, I'll stop the video and come back in another minute. That way you won't have to just sit here for a minute watching the same reaction. I'll come back. Class, 3 minutes has elapsed, and the directions say then to take the new temperature of the acid and magnesium after reaction, and you can record on your lab the temperature, 44.4 Celsius. So it went up from what, 18.6 or 18.7, something like that. So a considerable increase in temperature. All right, we'll move on to the next reaction, zinc plus hydrochloric acid. All right, class, here we are. I'm going to show you the little piece of zinc that we have. So you can see zinc. Again, looks like you might think zinc would look. This one actually comes in a sheet, which I've cut with a pair of tin snips to be in a little square. So let's pop that in, and we'll see what we see. Not very much happening, although I think maybe you can see that a small bubble has formed down near the bottom of the piece of zinc. I'm not sure if you can see, but look along the top edge of the zinc. Oh, a little bubble just flew up. Along the top edge of the zinc and the bottom edge of the zinc, again, maybe hard to see on the camera, I see a few tiny little bubbles forming. But definitely not as fizzy as magnesium. So I'll tell you what, we'll let this sit for the 3 minutes, and we'll come back to it, and then we'll take the temperature. All right, I'm going to go pause the camera, and we'll be back in another minute and a half. Let's come back to our zinc. All right, so hopefully you can see. Oh, I just knocked it over. But there were a few tiny little bubbles along the edge of the zinc. There, you can kind of see it. Okay, and then let's check out the temperature then. I'll hold the Okay, looks like we stabilized at 19.1. Whoop, 19.0. Either one will do, 19.0, 19.1. All right, that was the peak temperature. Now it's cooling down because the reaction has probably slowed down. All right, let's move on to aluminum. The aluminum here on the forceps, you can see it looks about like the zinc, maybe not quite as shiny in its natural state here, but let's go ahead and throw this into the acid. And watch what happens. Turn it to the side so you can kind of see along the surface. Doesn't look like a lot's happening. There might be 1 or 2 bubbles that appeared at the very bottom of the piece of aluminum. Okay, once again, I'll go with the elapsed time, and I will let this sit for another 2 minutes or so, and we'll come back and take the temperature. All right, Wildcats. All right, Wildcats, you can see that not much else has happened in the test tube with the aluminum, and we'll get the temperature. Temperature of the aluminum test tube at the end of 3 minutes, 18.7 C. All right, last one, calcium. Coming up. Okay, class, let's throw in the calcium. Calcium comes in these kind of lumps. Now normally it's a little bit kind of a dull gray. Sometimes the calcium though, when it sits out, it gets a white coating on its surface. The calcium actually ends up reacting a little bit with the oxygen in air to make calcium oxide, and that's the white, sort of that whitish stuff that you see on the outside. But calcium is a metal, And usually, if it hadn't reacted a little bit with oxygen and air, it would be sort of that dullish gray color that you see kind of beneath that white. So let's go ahead and throw in our calcium. I'll put in this lump, and then I'll throw in a second lump that I have sitting on the lab bench. Oh boy. Oh, look at that guy. I'm going to use this test tube holder to hold it up. Oh, very, very vigorous bubbling. Let me kind of bring it over to, maybe you can hear it if I get quiet. You can, I don't know if you can see, but as it's reacting, you can see some chunks of white stuff falling down to the bottom of the test tube. All right, excellent. We'll keep watching it for another 30 seconds or so, and then we'll pause it, and I'll come back with the temperature. Holy Moses, let's wait. It looks like that bubbles are climbing all the way up near the top of the test tube there. Holy smokes. Literally holy smokes. I can see some condensation coming out the top. All right, that was a good one. All right, so actually it looks like about 3 minutes have elapsed. And so I'll get the thermometer in there and we'll check out the temperature. Break up the bubbles. And we'll let the thermometer equilibrate, and then we'll bring it into view. Wow. Okay, it looks like around 79.9, 79.8, 79.9 it maxed out as. Now the reaction's slowing down, so the temperature might be going down a little. And let's let it stabilize there. Let me hold the thermometer. Whoop. Now we can probably say something like, I'll stop moving it, and then we'll let it hopefully settle down. Looks like it's going to go up and down, maybe because the reaction is slowing down. But definitely it was at least 80 degrees Celsius. So any one of those numbers that you saw that you liked, go ahead and write that down. But you can see it was a lot larger temperature increase than any of the other reactions. And of course the reaction looks like it's slowing down now, and I think that's why the temperature is creeping down. But at 3 minutes it was about around 80 degrees Celsius. All right, guys, I think that should be pretty much it for what you need to complete the analysis in the lab. One last look at the aftermath of our reaction between these 4 metals and hydrochloric acid. The lab then, as the last part of your data collection, is going to ask you to rate the relative rate of reaction now that you've seen all 4. And as it says in step 6 of the procedure, you're going to rate them as 1 as the most vigorous and 4 as the least vigorous. If you turn to page 2, you can see that what the questions are going to do on this lab are going to basically, kind of, as you can remember when we were talking about some of the patterns with atomic radius and ionization energy, what we want to do is try to look at the position of these 4 metals on the periodic table and try to come to some consensus as to what the pattern of reactivity is. That is, what is the pattern in a group, and what would be the pattern across a period. All right, and I believe the questions on the lab will kind of walk you through that analysis. All right, okay guys, that's it for today, and take care. All right, go Wildcats.